Greetings and welcome. This is Dr. BDY Sunil, Associate Professor, Mechanical Engineering Department, Institute of Aeronautical Engineering, Hyderabad. In this session, we will be learning about the definitions and terminologies in Introduction to Engineering Mechanics, which is Module 1 of your syllabus. Let us start the definitions and terminologies. The first definition or terminology is given as what is mechanics. So, in the introduction class of this module or introduction class of this subject, we have learned about the basics of mechanics. The definition of mechanics is given as it is the branch of physics which deals with the study of effect of force system acting on a particle or a rigid body which may be at rest or in motion. So here, as we have discussed previously, you can see the important points or important words here. The first one is the force system and the second one is the particle. Here the force system, as we have discussed, many number of or n number of forces acting on a body or a particle is termed as the force system, and the total criteria is considered as the system. And we can say that the particle is not limited to a size of any body. It may be as small as a molecule or a atom, or as big as a building. Anything that is going to be considered as a body in the problem or given field application, it is termed as the particle. So the definition of mechanics can be treated as it is the branch of physics which deals with the study of effect of force system acting on a particle or a rigid body which may be at rest or in motion. Coming to the next definition, that is what is statics. The definition says statics deals with the forces acting on the stationary bodies. So we know that engineering mechanics is being classified into various criteria in which the rigid body mechanics comes into picture, and in this rigid body mechanics we have got two types, which is statics and dynamics. So the static condition is where the object is considered to be at rest. We can say the object is in equilibrium state and it is not moving anywhere. So all the characteristics which we are going to identify for a given system where the object is not moving anywhere, that body is treated as the condition at rest, or we can say the total system is in static state. So the definition says statics deals with the forces acting on the stationary bodies. So the object will not move anywhere, the object will be stationary condition, and it is treated as it in rest. Next one is what is dynamics. So as discussed, dynamics is the study of forces on moving bodies. So if the object is not moving anywhere, we treat it as a static condition, and if the characteristics are studied on a moving object, then the system is considered to be in dynamic state. Okay, so the engineering mechanics part where we are going to study the characteristics on a moving body, then it is treated as the dynamic condition. And the application of forces when they are in motion, we can say it as the forces involvement in a system when the object is in moving condition. We can call it as the dynamic state of mechanics. Now the next one is the define kinematics. So the kinematics is the study of the geometry of motion. It is used to relate displacement, velocity, acceleration and time without reference to cause of the motion. So this kinematics part again is a part of the dynamics mechanics. Engineering mechanics dynamics part where we are going to study the object's movement, the characteristics on the moving objects, and if we are not going to consider the cause of the motion, we all know for an object to move we need some sort of force, whether it may be in a linear force or it may be in a torque system. Anyway, some sort of force is needed for the object to move. So here, when the object is moving and we are only going to study the velocity, time, displacement, acceleration criteria and not taking into consideration the forces involvement or the cause of the motion, then it is treated as the condition of kinematics. So the kinematics is the study of geometry of motion. Only motion criteria will be studied here. The movement of the object is considered alone, where we are not going to consider any type of forces that are involved in the cause of the motion. Next one is define kinetics. Here there is a small difference between the kinematics and kinetics part. The kinetics is defined as kinetics is the branch of classical mechanics that is concerned with the relationship between motion and its causes, specifically forces and torques. As we have discussed, the kinetics is the part where we are going to study all the possibilities of criteria where the motion is going to happen because of the velocity, the acceleration, the time as well, along with the forces that is making the object to move. So kinetics part, we are going to consider the force that is causing the motion or torque that is causing the motion, and the static part we are not going to consider, or the kinematics part we are not going to consider any forces that are causing the motion. So that is the difference between the kinematics and kinetics. So the kinetics says kinetics is the branch of classical mechanics that is concerned with the relationship between motion and its causes, specifically forces and torques. So coming to next one, explain the term rigid body. What is a rigid body? So the definition says a body is said to be rigid if the relative position of any two particles do not change under the action of force. Okay, so again here there are two important terms, where one is distance between two particles and the other one is force. Okay, so let us understand with some small example. Consider a body here as shown, and we all know that all the bodies are made with some particles. These are the particles consisted by the body. And if we consider two particles here, let us take these two particles, and the distance between these two particles is given as d, let us say. Now some force is applied onto this body. Let us say some force F is being applied onto this body at this point. This is the point of application of the force. If now the rigid body criteria comes into picture, if even though the force is being acted here, there is no change between the parts or the points in the object. Let us say these are two points are A and B. If the distance between these two points doesn't change even when the force of F is being applied, then this body is treated as the rigid body. That is the definition of rigid body. Okay, so simply we can say that a body which doesn't deform, okay, a body which doesn't deform even though some force is being applied, a body which doesn't deform even though some force is being applied, then this body is treated as the rigid body. So the definition says a body is said to be rigid if the relative position of any two particles, okay, the particles which we have considered as A and B, the relative position of any two particles do not change under the action of the force. That means even though application of number of forces, not only one force, even though there are number of forces acted in the system, then the particles positions doesn't change, that body is treated as the rigid body. Now coming to the next one, state Newton's first law. We have discussed in the theory part of the mechanics that the application of Newtonian laws and the laws of mechanics to a field problem is treated as the engineering mechanics, right? Whereas the field problem is nothing but the problem in a practical way, the practical application, the practical oriented problems. If we apply the Newtonian laws or and all the laws that we know into the field problem, then it is treated as the engineering mechanics. So in this regard, let us discuss what is this Newton's first law. The Newton's first law states that an object will remain at rest or in uniform motion in a straight line unless acted upon by an external force. So this is the law where we are going to see the phenomenon of inertia. As we have discussed in the syllabus, the phenomenon of inertia is nothing but the object will continue to move in its direction, or with velocity or acceleration, whatever it may be, the object will continue to move once it is been initiated. And we all know that the movement will be initiated because of some external force acting on it, right? So once the external force is acted upon on the body will continue to move in the direction which the initiation has been happened. Now, the first law states that an object will remain at rest or in uniform motion. This is for a simple understanding that if an object is placed somewhere, it will continue to be in the same position. The position won't change any time unless some external force is acted. That means if we catch up on the object and put it somewhere else, unless and until that happens, the object will continue to stay there itself. It won't be moving anywhere by itself. And in the dynamic criteria also, that is when the object is moving also, we can say that unless and until some external force is acted upon. Like take an example of the car which is traveling. When you are traveling in a car, the car is moving in a straight line. If you need to take the car a turn, either left or right, what you will do? You will try to move it into the right or left direction using your steering. That means unknowingly you are applying some external force onto the wheels so that the wheels will turn to the right or left and the car takes the turn. So that's the case. Here in this example, the movement of the wheels is happening because of you rotating or moving the steering. This is the case. Unless and until that happens, the car will move in a straight way. So that's the case. The Newton's first law states that an object will remain at rest or in uniform motion in a straight line unless acted upon by an external force. So this is the first law. Coming to the Newton's second law, state Newton's second law. The second law states that the rate of change of momentum of a body is directly proportional to the force applied. And this change in momentum takes place in a direction of the applied force. Right? So when you get to understand this statement, it is clearly showing the definition of the force here. We all know the force is defined as the product of mass and acceleration. And using this second law, we are going to derive the formula for force, that is mass into acceleration. We all know the momentum is nothing but product of mass and velocity, m into u, right? We all know the momentum is nothing but mass into velocity. So the change in momentum, nothing but the initial momentum and final momentum, the difference of the initial momentum and final momentum, or the final momentum and the initial momentum, and it is given that rate of change of momentum is treated as directly proportional to the force. That means by t, the change of momentum divided with time, it is directly proportional to the force involved. Right? So this is what the statement gives us the idea, and using this statement we will be defining the force criteria. Right? So the statement given by the Newton's second law states that the rate of change of momentum of a body is directly proportional to the force applied, and this change in momentum takes place in the direction of the applied force. The next one is state Newton's third law. So third law states that for every action there is an equal and opposite reaction. So this is very popular statement where we are going to see in many a number of cases that this statement, third law statement, is being observed here very frequently. Simple example would be a ball which is thrown vertically downwards. That is, when we are playing a ball and we leave it, or if we leave it freely, or you will be throwing the ball downwards onto the ground, what happens? The ball will exert some pressure onto the ground, and the application of this force, nothing but the force, application of the force onto the ground by the ball, the reaction would be the ground also exerts the same force onto the ball in the opposite direction. That would be the reaction. Here, if the application of force by the ball onto the ground is treated as the action, then the ground's application of force onto the ball in the reverse direction is treated as the reaction. So this is a very simple example to understand it. All the rocket propulsions, these things that will be working on this statement itself, Newton's third law. The law states that for every action there is an equal and opposite reaction. Coming to next one, explain law of transmissibility. We have seen this law. It states that the state of rest or motion of a rigid body is unaltered if a force acting on the body is replaced by another force of the same magnitude and direction, but acting anywhere on the body in the line of action of the replaced force. Right? So here, for understanding this, let us see an example. Let us consider a body where a force is being acted at the point O in this direction. The at the point O, the magnitude of the force, we are considering it as F. Okay. Now we know that the force will be having four characteristics. If we need to completely define a force, we need to specify four characteristics. One is magnitude, second one is direction, third one is line of action, and fourth one is point of application. Right? So all these four characteristics should be defined completely. So as you can see here, the line of action of this force is as shown here. Okay, this would be the line of action of the force. Now along this line of action, we can observe here, this is the line where the force is being acted. This is the area, or we can say this is the linear line where the line of action of the force is lying. Now what this transmissibility law states is, if we replace this force having the magnitude F in the line of action, here already we have seen, right? So the line of action is along this line. So we can say that, let us shift this force to a point O dash. Let us shift this force to a point O dash, and O dash is the point along the line of action of the force which is applied F, right? So, and we are applying the same force F along this line of action again at O dash. What we are doing? We are replacing this force F with the same magnitude, that is F force, at a point O dash, right? At a point O dash, and in the same direction. That means again this force's line of action would be on the same line, isn't it? Then this law states that even though you are changing the position of the force with the same direction and same magnitude to a different position, to a different point of application along the line of action of the force, then it states that the effect won't change. Okay, so the effect won't change even though you change this position. Effect, what is the meaning of the effect here? For example, the force F is applied initially at point O, right? Then we let us understand that it has got some deformation of 2 mm. let us say the deformation of 2 mm has been happened because of the application of this force F at point O. Then if we replace this F to the new point, that is O dash, then also the deformation will happen with the same magnitude, that is 2 mm. Similar deformation will happen. There won't be any change in the effect. So that's how the statement says, that is, if the state of rest or motion of a rigid body is unaltered, if a force acting on the body is replaced by another force of the same magnitude and direction. Here you need to understand that the magnitude direction of the force, magnitude and direction of the force is same. That you need to understand. Direction and magnitude is same as the previous application of the force. We are going to replace that. We will remove the initial point application and we will be shifting it to the second position or second point. Then acting anywhere on the body in the line of action of the force which is replaced. Okay, so the effect won't change, right? So the statement is given clearly. The state of rest or motion of a body is unaltered. It won't change. The effect won't change even though you change the position of the application of the force, and this should happen along the line of action, right? Along the line of action of the first force itself. That is important. Coming to next one. Explain Newton's law of gravitation. So the Newton's law of universal gravitation states that every particle attracts every other particle in the universe with a force which is directly proportional to the product of their masses and inversely proportional to the square of the distance between their centers. Right? For the representation, we can observe here that the formula which is given here, F is equal to G m1 m2 by d square. Let us consider as given in the figure two masses, that is m1 and m2 are two masses, and 1 and 2 are the two different bodies. Okay, so we can consider them as particles, and the distance between these two particles is d. So as per the statement, as per the Newton's law, it is given as every particle attracts every other particle in the universe with a force F. So as you can see, the force F is represented in the figure and it is being shown in the attraction way, opposite way. Force which is directly proportional to the product of their masses and inversely proportional to the square of the distance between their centers. So actually speaking, we can give it as F is proportional to m1 m2 by d square, right? And for removing the proportionality constant, we are applying this G, which is the universal gravitational constant. So the formula can be written as F is equal to G m1 m2 by d square. Coming to next one, what is a force system? And the definition says, when several forces act simultaneously on a body, then they constitute a system of force. Okay, so let us say there is a body and a number of forces are acting here in different directions. Let us say they are acting in different directions, F1, F2, F3, F4 and so on. Maybe number of forces are acting in the body, on a body. Then we can say that these four forces, that is F1, F2, F3 and F4, these four forces are treated as the force system. That means in the system, these four forces are acted upon. That is the understanding. So the force system is nothing but the number of forces that are acting simultaneously. At the same time, the forces should be acted upon, and these forces will be considered as the force system. So the number of forces acted on a body simultaneously are treated as the force system. Coming to next one, define particle. So the definition says, it is the matter having considerable mass but negligible dimension. So as we have discussed, particle is nothing but a very very small thing, and in the engineering mechanics problem, the particle is given to a name of the body which we are going to study, the characteristics which are being studied in the system or on a problem. The body which is being considered in that problem, we are going to give the name as the particle here. The next one is, what is composition of forces? And it states that the replacement of two forces by a single force having the same effect, right? Nothing but let us say there are two forces acting at this point O. There are two forces acting in this direction and in this direction, that is F1 and F2. Now if we remove these two forces, and those two forces will be replaced by a single force, F1 and F2 are replaced with the single force. This is happening because we are combining the two forces F1 and F2. We can show it as it is. So this can be again treated as the resultant, which we have discussed, right? Resultant force, we can say. What we are doing here, we are replacing the force F1 and F2, and we are combining these two forces and showing these two forces as a single force, that is F, acting on the same point O. So this F can be treated as the resultant also. How we have obtained this F? We have combined these two forces. So this is called as the composition of the force. And the statement given for this is the replacement of two forces by a single force having the same effect. Next one is, what is resolution of force? This is just the opposite of the previous definition which we have seen. Resolution is nothing but we are dividing the force. Okay. Let us say a force F is acted here. Sorry, at this point O. At this point O, some force F is being acted in this direction. Let us consider it with some inclination theta. At an angle of theta to the horizontal, the force F is being acted here. Now what we are doing, we are dividing this force into mutually perpendicular components in a horizontal direction and the vertical direction, and we are giving it as a term Fx and Fy. So these two forces Fx and Fy will be considered as the resolution of this force F. Which, how we have obtained this? We have obtained these Fx and Fy as the mutually perpendicular components of the force F, and we have divided it along the direction which is horizontal and vertical. So this can be treated as the resolution of the force. So the process of dividing the force into mutually perpendicular components which are equivalent to the given force is the resolution of the force. And the next one is, explain moment of force. So it is the turning effect produced by a force on a body on which it acts. Okay. So the moment is nothing but the turning effect. When a force is being applied in a rotational fashion, when the force is being applied onto a rotational fashion, then we can consider it as the moment. And this moment is defined as the product of the force into perpendicular distance between the moment center and the moment arm. So for understanding this, what is moment center and what is moment arm, let us say this is a body on which a force is being applied here. A force is being applied onto this point O, and this is the force F. Now if we need to consider the effect of this force from a point which is other than this point of application of the force, let us say that is A. If we need to consider the effect of this force F with respect to point A, then what we will do, generally considering, we can say by common sense that if this point A is considered as a stationary point, then by the application of this force F at some distance, and that distance we can take it as D, at some distance from this point A, then this object will be having some clockwise direction movement, clockwise direction rotation. right? So here in this way we can say that the moment, this system, this force is creating a moment to this object here now. So this point A is treated as the moment center. We call this as the moment center, and this force F, this is the force F, and this is called as the moment arm. This is the moment arm, and the product of these two will give the magnitude of the moment for this particular condition. Hence, the definition of the moment says that the product of application of the force, that is force into perpendicular distance between the applied force and the moment center. Coming to next one, define couple. And the definition says the two non-collinear parallel forces of equal magnitude and in opposite direction forms a couple. So understanding this, let us see an example again. There is a body, and there are two forces acting here. Let us say it is A and B. There are 2 points, and there is a force of F acting here in this direction, and again at point B there is a force of F acting in the opposite direction. So here, as you can see, because of the same force which is being acted at 2 different points in the opposite direction, what we will observe? We will observe a rotational movement, a clockwise. Here in this particular case, there will be a clockwise rotation, and this clockwise rotation will be symmetric. Equal rotation will be happening considering the moment center anywhere in between. So this will form a couple. This will form a couple. A simple example would be a tap that is being rotated for getting some water. We will be using the thumb finger and the index finger, and we will be rotating the tap in our cleaning areas, whatever it may be. And because of that application of same force onto the edges of the tap head, the tap will be opening or closing, and we will be seeing a twisting action there happening. And this application of two forces in the opposite direction, and the two forces magnitude is same, equal magnitude, and that will form a couple. Coming to next one, what is moment of couple? So the magnitude of the rotation is known as moment of couple. Nothing but, as we have seen, the application of two equal forces in the opposite direction will form a couple. Now if we multiply, or if we take a product of this applied force and the distance between the 2 points, that will be a moment of the couple. So it is the product of common magnitude of two forces and the perpendicular distance between the lines of action of these forces. Okay, the two forces which are being applied onto the points A and B, as we have seen previously, the distance between these two, let us say that is D, and the force which are being applied, that is, as these are the two equal forces, we can consider it as a single force, that is F, and the application of the F into D will give the magnitude of the moment of couple. Next one is define concurrent force system. In a concurrent force system, the lines of action of all forces in a system passes through a single point. Okay, so for understanding this, let us see an example. There is a body here, and there are number of forces acting in different various direction, let us say. Now let us take the line of action of this force is this line, and line of action of this force is this line, and line of action of this force is this line. So as you can see, all the line of actions of all the forces are passing through a single point O. So such forces F1, F2 and F3 in this system, the three forces are treated as the concurrent forces, and the system is called as the concurrent force system. Here you need to understand that not only directly the forces are acting at that point, but the lines of actions of all the forces are passing through a single point. Coming to the next one, define collinear force system. So it is defined as if the lines of action of all the forces lie along a single line. then it is called as collinear force system. So for understanding this, you can say the forces are acting on a single line. There is a line here, and at point A, point B and point C, there are three forces acting. One force is in this direction, another force is in this direction, and another force is in this direction. Here you can observe that all the lines of actions of the forces F1, F2 and F3 are lying on a single line. So these types of forces are called as the force system is called as the collinear force system. Next, state Varignon's theorem. So it is a very popular theorem which is used to identify the resultant or unknown forces that are acting in the system. The Varignon theorem states that the algebraic sum of the moment of all the forces must about any point is equal to the moment of their resultant force about the same point, right? So that means on a body, number of forces are acted upon, and we are going to consider the moments of all these forces F1, F2 and F3. We know the formula for moment, that is force into perpendicular distance between the moment center and the moment arm. So if we consider the moments of all these forces, that is moment 1 plus moment 2 plus moment 3, which is the complete moment of all these forces, this is equal to the let us say the resultant R. Resultant is R for this system. This would be equal to the moment of this R. The moment that is created by the force of the resultant, that is force R, the resultant R, considering the same moment center, that would be equal. This is what Varignon's theorem states. Okay, so the statement is given as the algebraic sum of the moment of all the forces about any point is equal to the moment of the resultant force about the same point. Next one is define equilibrium. So if the resultant of a number of forces acting on a body is 0, then that body is said to be in equilibrium, right? So the resultant must be 0 in any system. Even though number of forces are acting, F1, F2, F3 and so on, number of forces are acting in the system, the resultant of all the forces should be 0. That means all the forces should equate themselves. Even though the object is in stationary condition, that means the number of forces are acting in the system and the object will be in stationary condition, then we can say that the object is in equilibrium state. So this will happen only when the resultant value is 0 for a system of forces. And next one is equilibrant. A force that makes the system into equilibrium is called as an equilibrant force. So for understanding this, we have just now discussed what is an equilibrium state, right? Whether if the number of forces that are acting in the system are not equating themselves to 0, that means there is a resultant that is lying behind in the system. There is a resultant. If we are going to apply some force, into the system where the resultant is becoming 0, the resultant value is becoming 0. By this application of the force, the resultant is becoming 0. How it will happen? It will happen only when we are going to apply the same magnitude of the resultant. In the opposite direction of the resultant, then the resultant will be 0. So this opposite direction applied force, the same magnitude of the resultant, that force is called as the equilibrant. Okay, so a force that makes the system into equilibrium is called as an equilibrant force. Next one, what is free body diagram? The figure drawn for a body in the system by making the body isolated from all the contact surfaces and considering the reaction at contact surface which is perpendicular to the surface. Okay, so what we will do in a system, even though number of forces are acting, all the forces will be shown in the figure, and if there are any supports to this given figure, if there are any supports to this body, we will be removing all the supports and we will show the reactions. We will be showing the reactions because of those supports, and these reactions will be shown perpendicular to the body, or we can say the reactions will be acting normal to the body. Next, state Lemmys theorem. Lemmys theorem states that if any body is in equilibrium under the action of only three coplanar concurrent forces, then each force is directly proportional to the sine of the angle between the other two forces. So the representation can be given like this. Let us say the P, Q and R are the concurrent forces, three forces, and the angles between them are alpha, beta and gamma as shown here. Then we can say that P by sine alpha, which is the angle between the other two forces, and is equal to Q by sine beta is equal to R by sine gamma. So these are the important definitions and terminologies in this first module, which is the introduction to engineering mechanics. This completes the session. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.